Hi, my name is Jitin Palaparthi. I'm a consultant, technologist. I work on Go, Rust, Microservices, Docker, Kubernetes, Kafka, etc. I have delivered hundreds of trainings and did work on dozens of uh, large scale applications. Coming to the concept, the first session I discussed about introduction to Kafka. Here we will discuss about Kafka architecture. Right. We will discuss about the components in Kafka. So generally, if you go for Kafka, uh, I also discussed about the Kafka architecture, right? We discussed about Kafka is distributed. Generally, what happened is Kafka has got multiple brokers. Okay, so brokers are nothing but servers. For example, this is a broker one. Put it as broker one. Similarly, I have broker two. I have got broker three. I have three brokers basically. Three brokers means, in fact, three servers. I have three servers. So what is a broker? Broker is nothing but a server. Okay. Broker is nothing but a server. Why three? Why not four? Generally, these brokers they form a quorum. Okay, it's a cluster. The whole thing we call it as a Kafka cluster. You can call it as a Kafka cluster. You can consider it as a Kafka cluster. The whole cluster form a quorum. Okay, forming a quorum, they always work on n by 2. That means, what does it mean? Why odd number is three servers form a quorum. Why they form a quorum? Because one of the brokers is failed, is not no longer working. Generally, there is something called leader election. Okay, leader election works on consensus algorithm, which we call it as a raft algorithm. Always the quorum is formed, leader election happens with n by 2 plus 1. For example, there are three nodes inside the cluster. The whole thing is a cluster, three nodes inside the cluster. So these three nodes form a cluster. Three nodes form a cluster. Then any one of the nodes failed, then it is n by 2, 3 by 2, which is called 1 plus 1, which is called 2. For example, if you go for 4 node cluster, okay, 4 by 2, uh, which is called 2 plus 1, which is again 2. You see that 4 by 2 is 4 by 2, 2 plus 1, 3. You get 3. So 5 by 2, for example, 2, 2 plus 1, 3. Okay. 5 by 2 means 5 by 2 plus 1, n by 2 plus 1. The formula is always n by 2 plus 1. So always they give odd number. That is how we can obtain uh, the failures during failure. Odd number works very well for the quorum algorithm. Always to form a quorum, odd numbers work very well. Uh, because adding a broker is not a simple thing. Okay, adding a broker is not a simple thing. Adding a broker is always a complicated thing inside a cluster. They always go for odd number. The reason is odd number can give more options during failure. Fine. However, so there are three brokers in the Kafka. Three brokers are nothing but three machines. Okay, always think these three brokers. These three brokers are actually three machines. Okay, what this brokers consists of? Actually, there are producers produce the message. There are producers, those they produce message. Okay. So go back here. The first one is a broker. Even though here I wrote it as a producer, but it's a broker. Brokers are actually Kafka servers that store the data. Serve the data is a friend. Okay, it stores the data. All the data that goes into the Kafka is stored in any one of the brokers. Okay, based on a concept called partitions and topic and partitions. We'll discuss about it later on. But however, the data is ultimately stored inside the system, inside these brokers. Okay, physically inside the brokers in a log files. Basically, they are all stored in log files. Generally, we have multiple brokers. We cannot go ahead with Kafka with one broker. We should have multiple brokers. And each broker contains some partitions. There is a special concept called partitions, which is the compelling feature of Kafka. We will discuss about partitions. But each broker contains a partition, one or more partitions. Generally, it depends on the topic. We will discuss about it later on. But generally, if there are three brokers, there could be three partitions. It's not related to the brokers. You can have multiple technically you can have each one broker also can have more than one partition, but uh, generally the it depends on your requirement. It depends on uh, uh, each and every topic that you create. But however, generally people have three brokers. They create three partitions. And brokers can also replicate data for fault tolerance, which we call it as replicas, replications. So we have partitions, we have replications, which is what the broker contains. So what the broker is, broker contains the actual messages. Whatever the messages that you write in Kafka, those are stored inside the broker in the form of log files. Okay, that is the first thing. Each broker can contain multiple partitions. Partitions are different queues. You can assume that each partition is kind of a queue. That means we will discuss it. We will discuss about it. But a producer or multiple producers are producing messages. They go to different partitions. That means they go to different queues. They are not queues, but just for your understanding about the partition I'm talking about. What is the use of partition? Partition can be used for the scalability and parallel processing. Discuss about it little later. Brokers can replicate the data because replications is something. Whenever there is a failure happens because of the replication feature inside the data is replicated inside the broker. Okay, the failure can be overcome by using fault tolerance. By for fault tolerance, it can tolerate the failure so that it will really it does not impact your overall system. And the first one is called the producer. Producer, we talk about broker first because the brokers are the servers. Producers are actually sending data to Kafka topics. Okay, the producers send data to Kafka topics. Uh, what is topic? Topic is on what are we talking about right now? We are talking about a topic called Kafka, right? Similarly, when a message is sent, generally how the message is sent, who sends the message? A producer. Well, who is a producer? Producer could be an application, producer could be a database, producer could be generally a microservice, generally microservices most of the cases, or even the producer could be a small uh, device inside your truck. Producer could be of anything, right? Generally producers are applications. How do they send the data? They send the data, they serialize the data and convert it into byte form, and then they push the data into the Kafka cluster. That means ultimately they go to the brokers. How do they push the data? On based on what they push the data? They push the data on a topic. Topic is nothing but something like a table name. It's not a table name, but you can assume it a subject on what actually this particular message is serialized data record is pushed to, based on what, for what purpose. For example, you are in a Amazon shopping cart. For example, you purchase an item, then item purchased could be a topic. Okay. Generally, topic names are, most of the people they give topic names are past tense. Some people give some special characters, snake case with the dot operators, period operators, and all. But yeah, it depends on, again, organization to organization. But there are few conventions people follow as well. Topic is what actually, on what topic the message exchange happens. Okay, what is the topic? What is the table name, kind of a thing? All the data that is published to Kafka by producer is in the form of serialized record. That means it is in the form of bytes. The topics are pushed to partitioned across Kafka cluster. That means uh, if the messages are kept on being sent, is kept on sent by the producer to the Kafka cluster, okay, based on the partitions, the data is distributed. That means it doesn't mean that data always goes to one particular broker or one particular partition. Data is distributed across multiple partitions. That's how the parallelism can be achieved. And there are some drawbacks as well. We will discuss about it later on, and then we will see how we can come, how can we come up with those drawbacks. But however, it is to scale the system in a better way. So producer is the component that produces the messages. And the third one is called the topic. The topic is the category actually, or a channel to which the records are sent based on what you are sending records. For what you are sending records, for a topic. What the topic is about. As I said, item purchased could be a topic. Okay, new user added could be a topic. User added could be a topic. So based on the topic name, the kind of a message can be identified. So all the messages that are sent, messages means the serialized data that is being sent to Kafka cluster, they are all segregated based on the topic. That's the importance of topic. And the most important part of a topic is each topic that we create. Generally, we like table names, like we create some topics based on the purpose. The topic that we create, it is split into partitions. That means a topic can have multiple partitions. For example, item purchased could have three partitions. Okay, how do you really understand that how many partitions can have and stuff like that? It's purely based on actually the performance of your application. When you scale your application, when you do scale testing your application, then you understand actually. Just looking at it, we cannot say how many partitions you need. It depends on. But the partitions are configured for a topic. That's very important. Okay. What is the use of partitions? Partitions can do the parallel processing. Okay, each topic is split into multiple partitions. So when a message is sent on a topic, that can go to either one of the partitions. It doesn't go to all three partitions, same message. It can go either to partition 1, partition 2, or partition 3, or partition whatever the number of partitions it has got. And the data within the topic is retained for a configurable retention period. As I said earlier, the retention period is configurable. Generally, it is for 7 days. But some companies they go for 1 month. Some companies they even go for only 1 day. Okay. Their messages, they know that the messages are being processed. They know they got the acknowledgement and stuff like that. Then they don't want to keep the message. They can always change the retention period for 1 day as well. That's what the topic is. Default is 7 days. The balanced retention period is 7 days. 1 week, 7 days. Right. Coming back to the fourth one is called the actual partition. Partition is very, very important in Kafka. There are two things that you need to understand in Kafka. Number one is Kafka partition. Number two is how your consumer is behaving with the partition. If you understand these two things, actually, mm, you can understand the whole Kafka. How, what is called partition? Okay, and then how your consumers are dealing with partitions is these two very important things. Each partition is divided into each topic is actually divided into multiple partitions. What partitions does is partitions allow Kafka to scale horizontally by distributing data across brokers. Okay, the horizontal scalability can be achieved by sending data to multiple partitions across brokers. The data is distributed across multiple brokers. What does each partition contains? Actually, remember that each message that you sent into Kafka is an immutable sequence of record. Okay, that means you cannot alter or tamper the message. Once it is sent, that's it. It's logged. You cannot go and then recall or revoke the message or tamper the same message. It's a timestamp. It's an event information. So each partition is an ordered, that means on a topic there are multiple partitions. Each partition has got its own order. It's not the topic that has got an order, each partition has got an order. Okay, 10 messages are produced. For example, 3 go to partition 1, 3 go to partition 2, 4 goes to partition 3, for example. Okay, the order is 1, 2, 3 for partition 1, 1, 2, 3 for partition 2, 1, 2, 3, 4 for partition 3. It's not like 1, 2, 3 for partition 1, 4, 5, 6 for partition. It's not like that. Each partition maintains its own order. And then it is an immutable sequence of records. If you send the wrong data, then you need to send again the right data, then the number of the message would be increased, which we call it as an offset. We will discuss about that later on. Okay. And the fifth one is called the consumer. Consumers are actually consumes the message. They subscribe to topic or topics and then they read data from the partitions. Okay. There is also, that means consumers read data. Important thing is brokers doesn't do any kind of thing to send the data or to pull the data. Brokers don't pull the data from producers. Brokers don't push the data to consumers. It is the producers that push the data to brokers. It is the consumers that pulls the data from the brokers. But brokers just they keep the data, that's all. Brokers, if you need data, please come and then pick the data, self-service. Okay, brokers will not push the data to consumers. It's not a push mechanism from the consumer's perspective. It's a pull mechanism. It is not a pull mechanism from the producer's perspective. It's a push mechanism. Producers push data to broker, and broker doesn't do anything. You understand that it is the producer that push the data. It is the consumer that pulls the data. Broker says that okay, you can send the data to me, you can take the data from me, but broker is nothing to do with producer or consumer with respect to sending data or receiving data. They just receive the data and consumers can retrieve the data from the brokers. So consumers are so they subscribe to topic and then read the data from partitions. So how do they read the data from partition? What is the relationship between the partition and the consumer? Partitions and the consumers is a separate concept. I will explain it uh, in the coming lectures. There is also a concept called consumer group. Each message, once it is read, generally once it is read, for example, a message is produced by the producer for a topic, it goes to any one of the partitions. The consumer reads the message from the partition unless until really consumer would like to read again. Once it is read, that's it. The offset would be incremented and then the offset is positioned in such a way that the next message is the consumer would be ready to read the next message. But what if the same message has to be read by multiple times for multiple purposes? For example, an item is purchased, a message has to be sent, a email has to be sent, a notification has to be sent, invoice has to be generated with the same data, procurement gets updated, inventory gets updated, logistics should be updated, and delivery partner should be updated, for example. So the message information is same, but same message has to be consumed by multiple consumers. But according to Kafka, a consumer can consume message only once. It's not only once, you can consume multiple times, but the concept is unless until you go back and retrieve the same message because of the retention messages are retained in the system. You want to multiple consumers consume the same message, then you have to create a consumer group. That is the concept. You have to create the consumer group. Okay. And the second thing is called the Zookeeper. The next thing is called the Zookeeper. Zookeeper has been deprecated. With the advent of Kafka version 2.8, Zookeeper has been deprecated. Still, people are using Zookeeper. Okay. Zookeeper has been replaced by an internal raft algorithm called KRaft, Kafka Raft protocol, with the version 2.8 onwards. Initially, it was started as an experimental and then it was stabilized and standardized. Now, many organizations are using KRaft. The reason is Zookeeper is a separate component. What is the need of a Zookeeper? Zookeeper can manage the cluster. They establish the communication between multiple brokers. They maintain the metadata of the brokers. This metadata could be used for the reader election. But Zookeeper is an additional component. You have to form or manage the Zookeeper cluster because it's a high available component, right? High availability has to be achieved when all the components should be highly available, not only the Kafka. So the entire metadata management, uh, forming quorum, establishing communication between all the brokers and all is done by KRaft algorithm, KRaft component. Okay. There are some controllers. One of the controllers is that controller manages the state of the cluster. State of the cluster means maintaining the health of the brokers, establishing the communication between the brokers as well, and also partition assignment and then replication if of the messages. Everything is taken care by the controller. So we are not going to discuss about Zookeeper much. We are going to use the latest K-Raft algorithm, which is called Kafka Raft algorithm. Raft is a conscientious algorithm, uh, but K-Raft is specially designed for Kafka Raft algorithm. There are we are talking about vanilla Kafka, but there is also a uh, you know paid Kafka. Okay, Kafka managed service Kafka, which we call it as a Confluent. Confluent is the company that is very famous. They contribute a lot to Kafka. very famous for Kafka managed service. They give you something called schema registry that is available in Confluent Kafka. Schema registry means the messages that you send to Kafka are generally serialized raw messages. Okay. What if you are maintaining different versions of messages? Messages, what to do? Messages are sent, serialized and sent, but somewhere you have to deserialize the message into your structures or classes. You do marshal and unmarshal somewhere. Why do you need to deserialize message? Because you have some your business entities, business models are there. Okay, you cannot perform operations on a raw data. You have to perform operations once they are deserialized into your entities. What if those entities have different versions? What if the data is malformed? What if you are maintaining different versions of those entities? Everything is taken care by schema registry. Okay, schema registry is very important for the production grade applications. So if you want to utilize the schema registry and etc., you have to go for the paid version. Okay. What is event streaming? Event streaming is uh, capturing the real-time data that is generated as events. Event contains the payload with the timestamp always. Streaming means continuous flow of data. Okay. Continuous flow of data may be coming from different sources, like it's a data that is collected and then processed like in batches, or the data is coming from your application, maybe user actions, or system logs, or IoT device signals, etc. Or real-time processing of data, something like maybe the truck information is kept on coming, etc. We can say real-time processing of the data. Processing data is very important. Processing means the data is changed as well. It gets processed. You can see different use cases, real-time analytics, analyzing the data based on for the system performance, etc. Data pipelines. The data is flow data flows stream the data between systems, like maybe the data is coming to database, from database you are sending through some other warehouse components, data warehouses, so you are using Kafka in between. The data has to be processed in between or analyze the data. We can use Kafka data pipelines. Event driven applications means microservices are the best examples. IoT and monitoring, you know that a lot of things about IoT devices, Internet of Things, right? This is what actually various components of Kafka. This is a high level diagram. You have different brokers, different producers are producing the message on different various topics, topic 1, topics 2, and all. Each topic data is sent through different partitions. Each message is sent to different partitions. Okay. Partitions are tied together to the topics. If a message is produced by the producer, it goes to any one of the partition. It doesn't go to all three partitions. If there are three partitions, it goes to only one of the partitions. And consumers goes and then it pulls, consumers go and then pull the data from the Kafka brokers. That's what all the consumers are. Okay, you can also use connectors, the send, push, or pull the data from database connectors, from cloud events, from other message brokers, something like RabbitMQ, etc. There are many connectors are available. Communities are creating so many connectors as well. Okay, this is what the overall picture of Kafka. The next concept we will discuss about uh, why Kafka is very fast, and also we create a Kafka cluster, a simple one node, one broker Kafka cluster using Docker Compose. I have the file. I will explain that in my next session. Thank you very much.